This is section 6.2, and today we're going to be using our idea of proportions in some word problems. So in our first couple ones, I'm actually going to give you the proportion, and all you're really going to need to do is kind of sub in some numbers. But we're going to talk about how these proportions come to be, and then how we're going to solve. So this first one says that we're going to take the length of mn and put it over ms. So I'm actually just going to set up my proportion, how I'm going to need it, and we're just going to fill in all of these letters for sides, and we're going to put numbers in their places. So if I go to mn, so here's m and n, and if I draw between them, I hit that 8, and then it's supposed to go with rs, so I'm tracing from r to s, and I get 10. And then np, which is 4, goes with st, which is x. Same concept kind of applies. Even if I didn't have this, we would still be matching up corresponding sides, so that 8 would go with 10, the 4 would go with x, so it's exactly what we set up, just using kind of this proportion as kind of a scaffold to get there. So now we're going to cross multiply and divide, which is what we did in the previous lesson. So 10 times 4 would get you 40, 8 times x would be 8x, and then we'll divide both sides by 8. And 40 divided by 8 is just a whopping 5, and so that's our x value. Next one has the same kind of thing. We're going to end up solving for BA and BD, so two different things we're going to solve for in this one. Here's my proportion. I'm going to write that again right here, and then we're going to fill in some numbers. So first up is BD, and if I trace from B to D, there's actually not a number there. This x goes all the way from B all the way down to A. So I don't have anything for just BD, so I'm just going to leave BD there. That might be the thing I'm solving for in this one. Goes with DA, so DA is 3. Equals, then we've got BE on this side, so from B to E I hit the 18. And then E to C is right there, so that's 6. And we'll do our cross multiplying again, so I'm going to have a 6 times BD, which is kind of like our variable right now. And then 3 times 18, so we get 54. And then we're going to divide both sides by 6. So it looks like BD is 9. And that's one of the things we were supposed to find. The other thing we're supposed to find is BA, which is from here all the way down to the bottom. So if we know from B to D is 9, then the length all the way would just be 12. 9 plus that 3. A couple of terms we're going to use a lot this chapter. One is called a scale drawing, which is really just the same shape, different size. So this would be like a map. You know how we have like a map of Minnesota? It wouldn't make sense for it to be life size because that would kind of defeat the point. So it's the same shape. You always see your map in the shape of Minnesota. It's just going to be a much smaller version. Could also do that with like pictures in like a science book when you're looking at like a nucleus or an atom. Those pictures are so small you can't see them, so we blow them up in order to be able to see them. So that is also a scale drawing. So it's just same size, same shape, but a different size. And then the scale is usually found in the corner of a map. We would call it like the legend, but it tells you the ratio of, let's say the ratio describing the relationship. I can spell. The relationship of the drawing to the actual thing. Oops. And what I will say in class, what you'll hear me say a lot, is fake to real. And we'll do that a couple times here in our examples. So the first one says we've got this blueprint for a new phone. It shows the length of the screen to be 15 inches. So the length of the screen, this is a blueprint, so this would be fake, and this is 15 inches long. That's length. The actual length on the phone, so this is real, is going to be 6 inches. So this is real, and it's going to be 6 inches long. So it's kind of the information I have so far. I'm really just going to hone in on the numbers here. And they want to know what's the scale of the blueprint. So I have 15 inches to 6 inches. A common way for us to have scale is that the fake thing, the map or the blueprint, usually is in a unit of 1 to something. So 1 inch equals 2 miles, or 1 centimeter is 3 feet. So it's usually this first value, this fake value, that we like to be the 1. So in order to get 15 to turn into 1, I would need to divide by 15, and so we'll have to do that on the bottom as well. And when I do that, I actually get 0.4. Sorry, my light just turned off. There we go. So the scale of this particular blueprint could be 1 inch to 4 inches. So it just means that for every inch on the picture or the blueprint, it's actually only 0.4 inches in real life. Next up, you bought a model of the Reunion Tower in Dallas, Texas. Just so you know, because you would never know this, but unless you've been there, the Reunion Tower kind of has a pedestal and then it has a giant globe that kind of sits on top, so that's what it looks like. The actual building is 560 feet tall. So that's real information, 560 feet tall. Your model is only 10 inches tall, so that's fake. And the diameter of the dome on your scale or your figurine, your model, is about 2.1. So that's new information. So that's also 2.1 inches. I'll just put a D for diameter, but it was definitely on the fake side. That's on my model. Excuse me. So it's definitely not real. They would like to know what is the diameter of the actual dome. So that would be real, and diameter would go right here. So I am just going to take those numbers out. So I've got 10 inches to 560 feet, and then I've got 2.1 inches to X feet. Now, in this kind of problem, we don't need to worry about us not matching our labels. We've done this kind of before, like with our trees and acres example. These will kind of work themselves out in the end. The only time you have to worry that you're in the same unit of measure is when you just have a single fraction that you're attempting to reduce. That's when you have to be the same. When you are looking to solve, what actually happens is when you cross multiply, you would end up with 10x inches feet, which is super weird. On the other side, you would have 2.1 times 560, which is 1,176, again, inches feet. And so these labels are going to take care of themselves as we're trying to solve. So this is the one we're solving for. So I'm going to go ahead and divide by my 10 inches. So I'm going to get rid of the 10. I'm going to get rid of the inches. I'm going to get rid of the inches over here. So my X feet, what I'm trying to figure out is this 1176 divided by 10. So just move the decimal place over 1. So it's 117.6 feet. That's all that was left. So you don't have to write these every time. I just was kind of showing you mathematically how they will work themselves out in the end. Your answer will end up the way that you need it to be. These do not need to match when you are doing cross multiplying and dividing. Next up, I've got one saying that on average there's one teacher for every 20 students. So one teacher for every 20 students at LSHS. If there are approximately 1,800 students, so that will go down here because we need students and students to go together, then how many teachers are there? So we're going to cross multiply. I'm going to have 1 times 1,800, so I'll just have 1,800. And I've got 20x. Divide by 20, looks like I've got 90 teachers. So that's kind of our start today. Lots of word problems as you're learning how to use your proportions in word problems.